Alright, so this is a complex circuit problem. This is about as complex as I could possibly imagine having you guys do, and I probably wouldn't give you a test this hard. But it does have all different characteristics. Usually we might only have one or two different kinds of combinations. This one's got all the different ways you can kind of figure it out. So it's a good one to practice on. And so as with all of them, we're going to start with our table. Okay, so I'm going to go ahead and fill in what I know, which is the resistances, and oops, I forgot to give you guys the voltage. It's a 12-volt battery. Okay, so the circuit's got 12 volts, and each of the individual resistances are 4, 3, 6, 2, 4, and 8. Now, remember there are 5 ways you can solve this. Voltage map, series rule, parallel rule, Ohm's law, and equivalent resistance. Maybe with the 6th of splitting it. Okay, that sort of carries into the parallel idea. Okay, so obviously the only one I can do here is equivalent resistance. So I'm going to go ahead and do it. I'm going to do it real systematically. Okay, I'm going to combine, first I'm going to combine 5 and 6. Okay, so those two are just in parallel with each other. Which means that 1 over R 5, 6, or the combination of 5 and 6 is 1 over 4 plus 1 over 8. Turns out that R 5, 6 is equal to 8 thirds. And then we can combine them with number 4. And since this combination is in series with that one, I get R 4, 5, 6 is equal to 8 thirds plus 4, or, plus 2, or 14 thirds. I'm then going to combine 3 and 2. Okay, so R2, comma 3 is going to be 9. 3 plus 6. Now I've got this two combinations here. I've got this chunk here and this chunk here, and they are in parallel with each other. So if I want to do R, it's going to be 1 over R, 2, 3, 4, 5, 6 is equal to 1 over R2, 3 plus 1 over R4, 5, 6. And since I have R4, 5, 6 and R2, 3, I can get that coming out to be 3.07. If R2, 3, 4, 5, 6, 3.07. Okay? Which means that then when I add that, all of that as one resistor in series with R1, that's going to give me Req is equal to 7.07. Okay. Once I have that, obviously the first thing I'm going to do there, if I have 2 in the same row, is I'm going to Ohm's law it. That's going to give me a current of 1.7 amps. Now, if the current for the whole circuit is 1.7 amps, that means that the current through R1 is 1.7 amps, because R1 is, everything goes through R1. So I get 1.7 there, and then immediately I can do the voltage for R1, which is going to be 6.8. I just multiply I and R. Once I have that, I can voltage map it. So I know it was 12 volts on one side of R1, and it's going to go down 6.8 volts, which means it's 5.2 volts over here. And I'm going to take a second here. I'm going to erase the kind of like circles that I drew on the circuit, because I'm going to put other things on there now. All right. See. All right. So it's 5.2 there, which means it is 5.2 here and 5.2 there, and it's 0 here and 0 here. Now, because R2 and R3 don't interfere with R4, R5, and R6, okay, every electron that goes to splits comes back together, we can split this into 2 problems. The R2, 3 problem and the R4, 5, 6 problem. Okay, and what I mean by that is we can actually draw like separate circuits. Okay, the R2 and 3 are going to act the same as if our circuit was a battery with 5.2 volts and then just 1, 2. R2 equals 3, R3 equals 6. We already know that R2, 3 is equal to 9. We already found that, which means that the current through this whole chunk here is going to be 5.2 over 9, which is equal to, if I can find it, there it is, 0.58. So all of a sudden I got the current for these two. Which means then immediately I can find the voltages. 1.73 and 3.47. Alright, so now I'm going to have to do the same thing but with 2, 4, or 4, 5, and 6. Alright, I'm clearly running out of room here. I might need some of those equivalent resistances, so I'm going to erase what I just did with 2 and 3. I'm going to totally erase it. So now I've got this little chunk. It's got a resistor, splits, comes back together. That's R4, R5, and R6. And I'm actually going to do a whole new chart for this one. So now I've got this chart here. Okay, see? R4, R5, and R6. And again, VIR. All right, I'm going to look at it. I'm going to say, okay, I know the resistances 2, 4, and 8. I know that the voltage of the whole thing is 5.2. Now I just can solve this smaller problem. All right, I've managed to kind of isolate this smaller problem. This smaller problem, you can do the same process. Okay, so the first thing I'm going to do is I'm going to find REQ. I already know what REQ is. It's 4, 5, and 6. It's 14 over 3. Once I have that, I can then find the current, which is 1.12. Everything that goes through this chunk goes through R4. So 1.12. Again, I can find then the voltage, which is 2.24. Once I have that, I can do a voltage map. So it's 5.2 here, it's 0 down here. 5.2, I get down to 2, or sorry, I subtract 2.24, which leaves me with 2.96. And since I know it goes from 2.96 to 0 over 4, 5, and 6, it's 2.96, 2.96. And then I can find those currents, which are going to be 0.37 and 0.74. Plug all this back up into my main bit here. And I have solved this circuit. Got every part in there. Okay, and again, I did it by using 5 rules. Okay, current rule. Okay, series. Well, sorry, the series rule, which means that the current is the same if it's in series. Ohm's law. Okay, the parallel rule, which means you can split things into separate pieces if they are in parallel. Blanket on the other two. Voltage map and equivalent resistance. Okay? Those are 5 strategies, and there's a complex circuit.